Hello class, welcome to Pre-Algebra Lesson 3-4, which is all about describing proportional relationships using the constant of proportionality. So by the end of this lesson, you should be able to use the constant of proportionality in an equation to represent a proportional relationship. Here's a little fun side challenge. Anyone that can say constant of proportionality in an equation to represent a proportional relationship a couple of times fast, come see me, because I would love to hear that, and maybe I'll give you a piece of candy, because to me that's a tongue twister. Anyways, let's jump into math. So let's talk about a couple of key terms here. Constant of proportionality is going to be kind of our main idea today, and it sounds a lot scarier than it is. You've actually already been working with this. It's just we've called it other things so far, but I think you'll catch on really quickly. One thing to note here is we are going to use a variable or a very specific letter to represent the constant of proportionality. And remember, a variable, its only job is to represent an unknown value, so an unknown number, okay? So don't let the letters scare you. All it is, it's a placeholder for a number that we have not found yet. Okay, and then we're talking about an equation. That means that there has to be an equal sign. If there's no equal sign, it is not an equation. It is most likely an expression. Okay, and then proportional relationships, we've been working with those all chapter. Okay, let's dive in. Example 1, write an equation to represent a proportional relationship. Our example is we have a sponge, and a sponge is an example of something called a filter feeder. It takes in food by filtering water through its body. Okay, so the sponge maintains a constant flow of water through its body. And we want to figure out what is an equation that represents the proportional relationship between the time and the amount of water that the sponge filters. Okay, so you can see here's a lovely little diagram of a sponge. You can see we have all these arrows representing the water that comes in, and then an arrow representing that water is coming out of that sponge. Okay, and when it comes out, it is filtered. Then over here you can see that if you measure it, 8 liters of filtered water is produced in 10 hours from this sponge. But if you were to wait 15 hours, you'd get 12 liters. So we want to figure out what is the way that we could write an equation, so that way if I asked you how many liters are filtered in 200 hours, you could very quickly figure it out. Okay, so I'm going to do this problem kind of a long way, like take some time, talk through it, and my goal with that is so then we have a good understanding of how this works, so that way we can go a bit quicker or more quickly on the next couple of examples. Okay, so let's dive in. We know the information that we have. We have hours, okay, and then we also have the liters, right? Like if we were to make like a little table with the information we have hours and liters. I'm going to call hours my x value, liters my y value. Here's a little tip from math, and this goes for almost any and every math class. I actually cannot think of an example off the top of my head where this does not apply. That's how common and frequent it is. If you ever have a label that is a time, okay, so if you ever have a label that is a measurement of time, seconds, minutes, hours, days, weeks, months, years, decades, centuries, millennium, those are always going to be x. Your x value. Okay, in later math classes we'll talk about why that is, but for now just store that little tidbit in your brain. Okay, so hours is going to be your x value, liters is going to be your y. Now looking at this, we have 8 liters in 10 hours, so I would say 8 liters in 10 hours. And if I were to do the same process that we practiced just yesterday, if I was trying to find like the proportion between them, I would do liters divided by hours, right? Like my y divided by my x. So I do 8 divided by 10. And if I were to actually divide that out to a decimal, I would get 0.8. Okay, let's try with the other one. It is 12 liters in 15 hours. And if I were to do 12 divided by 15, again, I would get 0.8. And yesterday, this is the point where we'd say, yay, they match. We have a proportional relationship. Life is good. Let's move on. Well, now that we have that number that matches, we're going to give it a name. And that name, oh, it's too soon for some Christmas colors. That name for that number that matches, that is going to be called your constant of proportionality. You might be thinking, that's a lot of words to say, and you would be correct. That's why we're going to use a very specific letter, K. All right? So instead of saying constant of proportionality, most often for the rest of this video, you're going to hear me say K value, okay? And that's what I'm talking about. Now, once you know your constant of proportionality, so in this case, it's 0.8, so I'm going to say K equals 0.8. Now let me teach you a little equation that you can use from now until forever with proportional relationships. And that proportional relationship equation that we're going to use is y equals kx. And I know that's a lot of variables, but it looks not so scary once we plug in our actual k value. So now I just have y equals 0.8x. And that right there is going to be my equation. Okay, so the question was, what is an equation that represents the proportional relationship? This right here is my answer. And like I said, a reason this is really helpful is, what if I wanted to know, like, how many liters would be filtered in 200 hours, I think is what I had said. All I would have to do is I would say y equals 0.8, and then for x, I would type in 200. So I would say 0.8 times 200, that's 160, and yes, I do have a calculator in my hand right now. So I would know that in 200 hours, it filters 160 liters of water. Okay, so you can see how this can be a really useful tool to have, to know how to use, okay? Even if it's not necessarily that you're calculating number of liters of filtered water from a sponge. Promise there's a lot more applications than that, but I think that's kind of a fun one. All right, now it's your turn to try writing an equation. So I gave you some structure here. We have Maria made 2 batches of fruit punch. The table shows how many quarts of juice she used for each batch. Write an equation that relates the proportional quantities. So what I want you to do here is I want you to fill in those boxes. Okay, so we have one box here, we have a second box here, a third one right here, and a fourth one right here. I want all 4 of those boxes filled in, and then I want you to unpause the video and check to see how you did. Good luck. All right, for this problem, hopefully you figured out that in that first box you would do 8 divided by 5, which equals 1.6, and then the second box you would do 16 divided by 10, which would give us 1.6. And that's great news because that matches. So that tells us our constant of proportionality, or our k value, is 1.6. And that means an equation that represents this proportional relationship is y equals 1.6x. All right, let's move on to our second problem. We want to be able to use this type of equation to solve some problems. So let's say 1 inch equals 2.54 centimeters, and yes, that is a fact, that is true. And I want to ask you, how many centimeters long is an 18-inch ruler? So the way that we would do that, we're going to use that y equals kx, okay? And I'm going to say that y is going to represent my centimeters. Centimeters. And then x is going to represent my inches. And then k is going to represent my constant of proportionality, which in this case is going to be 2.54. So if I were to write this equation out, it would look something like this. I would have y equals 2.54x. And then the question asks specifically about how many centimeters long is an 18-inch ruler. So I'd say y equals 2.54. And then maybe you've noticed that I have a habit of, instead of writing multiplication signs, I will often do parentheses. It means the same thing. Okay, so y equals 2.54 parentheses 18. That is the same as if I were to write y equals 2.54 times 18. Okay, they're the same thing. My preference is usually just to use some parentheses, but you can do whatever you're most comfortable with, okay, as long as you're multiplying. And then if I were to actually multiply that out, I would get y equals 45.72. So I would say an 18-inch ruler is 45.72 centimeters long. And that would be my final answer. All right, so using that same process, I want you to look at this problem. We have a florist sells a dozen roses for $35.40. She sells individual roses for the same unit cost. Write an equation to represent the relationship between the number of roses x and the total cost of roses y. How much, would 18 roses cost? Now you'll notice I underlined unit cost, and the reason I did that is because you have to figure out the unit cost with this information right here. Remember, a dozen means 12. So what you want to do is you want to figure out how much is one rose. If I know 12 is $35.40. So find that unit cost, and that unit cost is going to be your K value. That's your constant of proportionality. Okay, so unit cost and constant of proportionality can be the same thing. Good luck. All right. For this problem, hopefully you figured out that the K value is $2.95, and then once you multiplied that with 18, you got 53.1. But if we're talking about money, we always need two decimal places. So I am going to say $53.10. So your work should match mine or look very, very similar. If not, look to see what kind of differences do you have in your work and answer, and make sure you understand what happened in your work that you maybe didn't arrive at the correct answer. And if you're unsure, ask me. I am happy to help you. I love working with you guys. Let's move on to example 3. Determine whether y equals kx describes a situation. Okay, so this application, this formula that I have taught you today, does not always work. Okay, and I'm going to teach you how to know when you can use it and when you cannot use it. All right, so looking at this problem, we have, can you represent the total cost y for admission and x rides at the amusement park using an equation in the form y equals kx? Explain. Now some of you have maybe already made the connection. Well, if you're asking this, chances are no. But let me explain why, okay? You would be correct. The answer is no. But let me show you why. Looking over here, we see that admission is $20 to get in, and each ride is $5. So if you were to get into the park to go on one ride, it would be $25, right? So I would do 25 divided by 1. Well, that's just going to be 25, right? And then if you were to do 2 rides, well, that would be $10 for rides plus the $20 of admission. So that'd be $30 for 2 rides. And that's going to be a 15. Now, do you notice right away, 25 and 15, those are not the same number. That means that this relationship is not proportional, and that means that we cannot use that equation, okay? If I were to even go one step further, I would see, yeah, nope, this isn't going to work, okay? So always check to see, do you have a constant of proportionality? If not, you cannot use y equals kx. So what you would say for an answer would be, since these do not match, it is not proportional, so we cannot use y equals kx. All right, then here's the last thing for you to try on this problem. We have balloon A is released 5 feet above the ground. Balloon B is released at ground level. Both balloons rise at a constant rate. Which situation can you represent using an equation of the form, sorry for that typo, form y equals kx, and explain? So I want you to look at these two different tables. So we have balloon A right here, balloon B here. I want you to determine which one can be represented using y equals kx. So that means it has that constant of proportionality, right? And I just give you a hint on what the explanation is. So go ahead and solve this one on your own. Good luck. All right, for this problem, hopefully you determined that balloon B would be the balloon that we could represent with the equation y equals kx. The equation would be y equals 4x. And the reason it's balloon B is because it represents a proportional relationship. It has that constant of proportionality of 4 amongst all of them. Okay, so if you have questions about that problem, or honestly anything else from this lesson, here's a little key concept. But please ask questions. I am more than happy to help you. I want to make sure that you understand this, and that is honestly everything for today. I hope you have a great day.